Sorry about that. My cell phone kind of cut off. Got a text message. You can see we got this one still pretty much full sized. This one from the CPU, there's nothing left. It's completely melted, which, with as hot as the CPU gets, you would kind of hope that would be the case. Here's our control group for control situation. Not very much changed, except for just that little corner of it that kind of actually hit the heatsink over here and melted pretty quickly. Now, I mean, mind you, see there's this water puddle here. That's going to slow things down since you got your water with your 4.184 joules per grams Kelvin specific heat. So if we were to dump that off, my hypothesis here is that that's going to kind of speed up the melting process again. And as I kind of watch it, it looks like the ice cube just kind of really quickly melts again. Because obviously this metal is going to have a much lower specific heat, which is to say that it takes less energy, which we say in joules, to transform or change 1 gram of substance of metal or of ice cube or of plate or whatever, food in your microwave. It takes less energy to transform that 1 degree Celsius or Kelvin if it's a metal than it does for water. Water has a very high specific heat, which is why pretty much all biological systems use water to kind of thermoregulate. You'll see here, this one's got its little pool of water again. Here's our control situation kind of sliding under. Not much changed, still looks pretty much like a normal ice cube. This one is not too changed. We can maybe dump off a little water from this one, see if that changes anything. And like I said, this one from our central processing unit, that just went really quickly, which is kind of different from what happened last time, because last time this one on the video card was the fastest by long shot. It looks like it's still working its way. Probably going to be ever so slightly faster than this one from the chip on the motherboard. I'm just going to set that one up there. Maybe we can set this control group over here so it doesn't keep melting its way across the plate onto these other two. Then leave these other two and see how they go. Maybe it's kind of got their pool of water, obviously, from the melted ice. Now remember, the whole purpose of this one is that these flat surfaces are going to be the surfaces that are actually in contact with the chip or processor on your computer or video card or whatever it's trying to cool. Very similar to the coolant running through your car, your engine, and the tines are just like your radiator trying to dissipate that heat and get it away to cool off quicker than it normally would if there was just air blowing by. And it looks like we've only got about maybe 30 to 45 seconds more probably before these guys would melt. And here's our little control situation, just still going pretty slowly, and it feels like it was actually even hollow to begin with. So that's that much less water that one had to melt. Let's dump these off again. so that water's not helping itself as far as specific heat, and keeping things all at constant temperature, because that's obviously the purpose of these, is to not let the processor keep a constant temperature. The purpose of these guys is to take the temperature and drastically change it from what would be natural. And it's close enough, I'm going to go ahead and call that good. That they don't really have much ice here, and remember, several minutes ago this one from the CPU went away, and here's our control situation, still pretty solid. And once again, there's how a heatsink dissipates heat in your computer to help your computer operate at a lot higher temperatures and cool very efficiently.